Okay, so the first thing we're going to do is combine everything we've learned in terms of functions and modules, and we're going to write ourselves a module that contains a number of different functions to do some basic statistics and learn how to build up more complicated tasks from very simple ones. So, open a new text editor, which you should be used to doing by now, which, again, turn off smart quotes. It might have turned back on magically. Turn off your rich text formatting. Make sure it's nice and plain page. And then the first thing I'm going to do is put a code comment at the top of my file to tell me what this file is. It's a good habit to get into. And so I'm telling myself that this file will contain functions to analyze values in a list. The first function I'm going to define is going to be very simple, and it's just a recap of how to write a function. I'm going to print the numbers in some list. So every function we're going to write in this module will take a list of numbers and do something on it. So the first function is just going to print the numbers in the list. So to define a function, remember we have that def keyword. Def, I've called my function printNums. After the function name is where you put the inputs. And so this function has one input, which I've called numbers. Then we have a colon, a new line, an indentation. And the code just says, for num in numbers, print num. And that means it'll take the first number from the list the first time, print it, take the second number from the list the second time, and print it, etc., etc. So this will go through our list of numbers and print every number in our list. Okay, so that's the first function in our module. I'm going to leave, hopefully it's still there. There we go. So within the same file, we can add another function because we're building up a module with multiple functions. And our second function is going to calculate the sum of a list of numbers. Now, once again, this starts with a code comment to tell me what this specific function does. And I want you to be aware of the indentation of my code and try and make sure that yours is the same. The for loop in my print numbers function is indented, and then the print is indented again. So for the sum of numbers function, again, the keyword def, the title sumNums is the name of my function. Again, it's going to take one input. This I've called numbers. It's going to be my list of numbers. I start with a total equal to 0, and that's going to be populated with our sum of our list as we go through. And then to calculate the total, I'm just doing for num in numbers, total plus equals num. And don't forget that total plus equals num is the same as saying total equals total plus num. So total plus equals num is just going to add the new number to the total. The total that starts at 0, if it picks out a 7, the total will become 7. If it picks out a 10, the total will become 17. It's just going to add a running total. And the final thing I want my sumNums function to do is return that total. Remember, the return keyword means this is the output from my function. So the sumNums function has one input, a list of numbers, and one output, which is the total. And it's going to add them all up. Everyone see how that calculates the sum of a list of numbers? Awesome. Okay, so still within the same file, under my sum of numbers function, I'm going to add another function. So this is building up a module, one function at a time. This function is going to calculate the mean average of our list of numbers. So again, a code comment to tell me what it's doing. And then again, a function definition, def average nums. It takes one input still, and that's the list of numbers. Colon, new line, indentation. Now the first thing I need to calculate the mean average is the sum of my list of numbers. Now I could rewrite some code here to go through and calculate the sum, or what I've done is use my sum of numbers function to calculate the sum of my list of numbers. So I'm calling one of my functions from one of my other functions. I've just written some code to calculate the sum, so it would be silly to retype that code when I could use that function I just defined. Hey.
When you're using a symbol, do you always have to flag it with spaces? Or no?
No. White space in Python is important at the start of the line, but in terms of gaps between spaces and things, that's up to you. This is just to make it clearer on the board. Okay, so we know our sumNums function will take a list of numbers and the output will be the sum of that list. So I'm going to use that, I'm going to call it on our list of numbers, and I'm going to store the returned value in a variable called sumOfNums. So this sumOfNums variable will get whatever is returned from calling sumNums on our list of numbers. So I want you to be aware of the input list being passed from here, where it was the input, down into the sumOfNums function, where it becomes the input of this function, which calculates the total and returns it back to the sumOfNums variable. So now we have the output of that sumNums function stored in the sumOfNums variable. So then the final thing I need to do is divide that sum by the length of the list of numbers to get the mean average. So once I've got the sum, I just divide it by how many elements are in our list, and then I have the average. So the number of elements in the list is len, which will tell us there's 10 elements in the list if there's 10. And note, I've done a float casting on one side of my division to make sure that I don't have a problem with integer division. And so that is our average value, and that is what is then returned from our average nums function. So the mean average is returned given the input being a list of numbers. So always look at a function with the inputs and then the outputs after the return statement. Okay, so now we have an average nums function, which is using our sumNums function. So we're going to extend our module even further. This is our average function, and below that I've added another function. This next function is going to calculate the variance of a list of numbers. So I again have a code comment to tell me that I'm calculating the variance. And the first thing I'm going to do in my variance function is define an empty list of zeros ready to fill with values. So I have the same function definition and the same inputs that we had before, but this first line in our variance num function looks a little different to anything we've seen before. To help you understand it, there's a little crop from the terminal down the bottom right. So what I'm doing here is I'm creating a list of zeros that is the same length as my input list. So if I have 5 numbers in my input list, I'm getting a list of 5 zeros ready to fill with values that's going to be used to calculate my variance. So in this example, you can see if I create a variable called myList that is 0 multiplied by 5, the result is 5 zeros in a list. So if my list of numbers here is 10 long, then this will be a list of 10 zeros. So I have this variance variable now that contains a bunch of zeros the same length as my input list. So the other thing we need to calculate the variance is the average, is the mean average. So I run my average nums function on my list of numbers, which we know calculates the average. We know it also uses my sumOfNums function. So this function is calling not one but 2 of our other functions within this module. And you can see this is how sort of more complicated code is built up from simple functions. So the average nums function will calculate the average of our list of numbers, and we're going to store that in this average variable. So now we have 2 variables ready for our variance calculation. One is an empty list of zeros, and one is the mean average of our list. So the algorithm I use to calculate the variance is to go through for every number in our list of numbers and calculate the distance from the mean squared. So num minus average will be the difference between that number and the average. We then square it, and we then store it in the list of zeros in the same place that it was in the input list. So that sounds a little strange, but what it will do is it will take the first number out of the list, calculate the distance of that number from the average, square it, and then store that square distance in the first space of our variance list of zeros. It will then take the second number out, calculate the square distance of that from the mean, and store that in the second place of our list of zeros. So we are gradually converting this list of zeros into a list of square distances. And to make sure we put it in the same place that it comes from, we use this index function. So we saw before that when we used .index on a list, on a sequence list, it found out where the number first occurred in the list. So if we had A, C, T, G, and we did index of C, it would say it's not at the 0th position, that it's at the second, it's at the first position because we start counting at 0. So this figures out where in the list the number came from and uses that index to store the square distance from the mean of our number. So if the number comes from position 1, it will go into position 1 in our variance list. And once we've done that, we need the mean of that list. So the mean of the list of square distances is going to be the variance, and so we call our average nums function one more time on the variance list, which will now contain all of our square distances from the mean. So just to recap that algorithm, we figure out the mean, we calculate the square distance of every number in our list from the mean, store that square distance in another list, and then calculate the average of that list. And that will give us the variance. So this variance nums function will return the result of calling the average num function on our list of square distances. Okay, and you may be able to guess what's coming next, and that is to finally calculate the standard deviation using our variance, and that's one more function within the same file. Okay, so once again, def keyword, the name of my function, this time std_devnums for the standard deviation of our numbers. Once again, all these functions just take a list of numbers as an input. The first thing I need for calculating the standard deviation is the variance, so I call my variance nums function on my list of numbers, which will then calculate the variance. And I store that in this variance variable. And then the final thing I need to do is take the square root of the variance. I introduced a little error handling here. It's more of an example. You don't need to include it. You can if you want to, and you can deal with different error types if you want to. But it's just an example of how you might handle some errors within some code like this. So I try and return the square root of the variance. If I get, for example, a type error, I will print that the wrong data type was received. We might want to deal with different error types, and you can change the type error here and add other error types if you want to handle different types of errors. Okay, so once you've typed all of that, save it as mystats.py, save it into your home directory where you've been working before, and then what we're going to do is we're going to import it and use it. So it should look like this. I can put the code back on the board for anyone that's still copying in a second, but here's how you will call it. You will do import mystats, so that's the key bit that's missing from the board. We will do import my stats, and then after you've done import.mystats, you can run mystats.std_devnums, give it a list of numbers, and you should get the standard deviation of that list of numbers. Just to test and verify, what I did was I also use the variance nums function on my list of numbers and took the square root of that and got the same answer. So yeah, this is a general sort of approach to how you would write more complicated things. Rather than writing a big function that has 500 lines and does a bunch of crazy things, I would encourage you to break it into small tasks like we did here and connect these functions together with writing basic functions that do basic things and calling them from each other, for example. So just to recap, the way the list of numbers is passed around, it's important to understand how the input from one function becomes the input to another. So when I run mystats.std_devnums on this list is passed as the input to my std_devnums function. So this numbers variable is that list. That numbers variable is then passed into my variance numbers function. So the variance number function gets that list as an input. The variance number function then calls the average number function and passes that list up into the average number function. The average number function gets the list, passes it to the sum of numbers function. So this numbers variable is still that list. The sum of numbers function calculates the sum and returns it to wherever it was called from. So the sum of numbers function was called from here, and the sum value is returned up to sum of nums. The average number function returns the average up to wherever it was called from, which is here. And the average number function will return the average, which will be stored here, and then the variance number function will return the variance to wherever it was called from, which was the standard deviation function, and the variance is passed all the way back up to the standard deviation function. So the numbers list is passed all the way down, and then the results are passed all the way back up to the standard deviation function. So it's a little hard to get your head around, but I'll let you look at the code more later if you need to and figure out where things are passed to. But just be aware that the inputs here are passed as inputs to other functions, and so the numbers list is passed around with each function doing its own job on the list of numbers.